So, example 8 tells us to solve the square root of x plus 9 minus the square root of 2x equals 3. Identify any extraneous solutions. So we're continuing on this whole radical equation idea that chapter 5.4 is all about. And the difference between this problem and every problem we've seen to this point is we have multiple radical pieces. We have a square root of x minus 9, or x plus 9. We have a minus the square root of 2x. And we have a 3, which is just a friendly little 3 just hanging out that it equals. So it's an equation because it equals 3, and it's got multiple radicals. So, as with the other radical equations, I need to isolate the radicals, what I've always said, but now there's more than one radical, so I have to isolate a radical. I can either isolate the square root of x plus 9 or negative square root of 2x. It really doesn't matter which one. Okay? I'm going to just, since this one's negative, if I move it across it becomes positive. I like positives better, so I'm going to move the square root of 2x over there. So, the square root of x plus 9 is staying exactly as it is, right where it's at on the left-hand side. Nothing happens to it. 3 is staying right where it's at, so nothing happens to it. The negative square root of 2x moves to the right, becomes positive the square root of 2x. Okay, so using good algebra to move that across the equal sign is step 1. And again, my priority here, I don't care what happens to everything else. All I'm looking at is I want one of the radicals isolated. Radical all by itself equals everything else. I don't care what everything else looks like. Step 2. Once I've isolated a radical, I'm going to get rid of the radical the same way we've been getting rid of radicals. I'm going to raise both sides to the power that gets rid of it. This is a square root, so I'm going to take this to the second power. So I have to take the right-hand side to the second power. The right-hand side is a binomial, object 1, 3, object 2, positive square root of 2x, binomial to the second power. So on the right-hand side here, I'm going to do 3 squared is 9. I'm going to add 2 times the product of the two objects, 2 times 3 times the square root of 2x. And then the square root of 2x times itself is going to be plus 2x. Just using our algorithm for squaring a binomial, it tells us to square the first object. It tells us to double the product of the two objects. And it tells us to square the second object. We can beautify that in a moment. Over on this side, square root of x plus 9 times itself just makes x plus 9. So the square root square gets rid of the radical. And we're left here. And notice the original problem has 2 radicals. After doing this step, we only have 1 radical. That's our whole purpose for doing all this stuff. We want to make radicals go away. We have 2 radicals. We have to do it twice. Next thing is to beautify this as much as possible. I want to add like terms, simplify stuff, whatever. So I've got my x plus 9 kind of hanging out while the right-hand side is being fixed. 9 is the only constant. 2x is the only x. And this product here is just going to be positive because everything's positive. 2 times 3 is 6 outside the radical, square root of 2x inside the radical. So after you've completely simplified that, that's pretty much step 1 in a nutshell. Square both sides, get rid of the radical, and then just beautify it up a little bit. If you did it properly, we started off with 2 radicals, we should be down to 1 radical object. At this point, my job now is to isolate that radical. Okay, so the leftover radical now needs to be isolated. Everything that's not that radical needs to move over. Anything being added, subtracted, multiplied, divided needs to be gone. So I'm going to move the 9 over here, so minus 9. I'll move the 2x over here, so minus 2x. I'm choosing to move things over here because I like my radical object positive, and it is positive, so I'm going to leave it where it's at. If this happened to be a negative 6 square root of 2x, I'd probably move it over here and the other stuff over there. I like the radical term positive. To me, it's easier. So if I carry out the addition and subtraction here, x minus 2x makes negative x. 9 minus 9 happens to cancel. So we get negative x equals 6 times the square root of 2x. That got rid of the addition and subtraction parts to it. Right now we have a multiplication part. I'm going to divide by 6 here, divide by 6 here, And that gets me the leftover, all the stuff to isolate. I'm going to get negative x over 6 equals the square root of 2x. Again, every time you want to get rid of a radical, isolate that radical, and then take both sides to the power that gets rid of the radical. So, this is a square root of 2x, so I'm going to square to get rid of it. So I have to square this side as well. When I carry out the squaring, when I say a fraction squared, I don't know if you guys are getting this as well as you're supposed to, but when you say a fraction squared, you simply square the top, you square the bottom. When you square anything, you're multiplying it by itself, so signs inside the parentheses, this whole thing's being squared. This negative is being multiplied by itself, so two negatives make a positive. X times x makes x squared. On the bottom, 6 times 6 makes 36. If you're squaring a fraction, cubing a fraction, anything to a fraction, the top and bottom both get affected by that power. On the right-hand side, I'm going to get 2x. For me personally, I prefer not to have fractions in an equation if I can avoid it. It was kind of necessary here because I needed the radical isolated, but now that we got the radical gone, now I'm looking at solving this equation here. I would probably multiply by 36 to get rid of the fraction. 36 times that fraction makes x squared. 36 times 2x makes 72x. So we get x squared is equal to 72x. I'm going to move the 72x to the left, so x squared minus 72x equals 0. Now here's another point. There was a problem, I think on the worksheet I gave you the other day, where this thing happened. The number wasn't quite so large on the worksheet, but there was no number. There was no like plus 6 or minus 10 at the end of it. It was just x squared and x, right? And all this quadratic trinomial factoring I was talking about, I didn't really focus back on this because I thought, well, everybody knows how to factor greatest common factor, but then I had a whole bunch of people saying, I don't know how to factor this. There's no number. How do I do this? So keep in mind, if there's no number, x is in this one, x is in this one, there's a common factor of x, and you can take that x out, and now it's factored. Okay. If you see a common factor, something that's in both objects, you can take that out legally. So I created factored form. The whole goal of factoring is you want to go from a quadratic x to the second power structure into a bunch of linear x to the first power structure. So either x equals 0 or x minus 72 equals 0, which means x equals 72. So there's my candidate answers for this problem, 0 and 72. They either work or they don't. My last task is to go back to the original problem, which is right up here. Before we modified it whatsoever, right here, I'm going to replace x with the number 0, see if it works. Replace x with the number 72, see if it works. So let's try 0 first. X equals 0 is my attempt here. I got the square root of x plus 9 minus the square root of 2 times x equals 3, maybe. So I'm trying x equals 0, so 0 goes in place of this x, and 0 goes in place of that x. What's 0 plus 9? What's the square root of 9? 3. What's 2 times 0? What's the square root of 0? 0. Does 3 minus 0 equal 3? Sure does. So x equals 0 works. Okay. My other candidate answer is positive 72. So again, I'm trying x equals 72. My structure is the square root of x plus 9 minus the square root of 2 times x is supposed to equal 3, maybe. We're replacing the x's with the number 72, so 72 goes here, 72 goes there. What's 72 plus 9? 81. And 81 square root is? 9. So that's 9. What's 72 times 2?
144.
Square root of 144 is?
12.
12. 9 minus 12 might equal 3. Does 9 minus 12 equal 3?
No.
No, it equals negative 3, right? This is a false statement, so x equals 72 is no good. We throw that one out. The only good answer to this is x equals 0. And once you get a solution set, once you get this, here's a list of numbers that could possibly work because the math made it work. When you start squaring both sides, this type of stuff can happen over here, where you get an answer that theoretically works, but in reality, back in the original problem, since we created some sign issues somewhere, it doesn't work.